Hi everybody, that's the second session for classification of signals. In this video, we're going to explain the periodicity condition of a signal. If we have a continuous time signal, it's going to be called periodic if the signal is repeated every time t. So that's t, it's the period of the signal. How can you know that? Let me just take an example. That's a signal here. We observe that it's repeated all the time. If we pick at t equals 0 this line, at t equals 0, and then it's going down and going up, and then it's going to end here and at 4, and it's going to be repeated again. And even to the left, if you look at it, if you put the line there, you'll find it's the same pattern. You see, it's going down and up, and then down, up. So this will be considered as one period, T capital. So how can you find the period? T should be a positive number, the smallest time that's going to repeat it after that. So it's from 0 to 4. So you can say that the period is equal to 4 seconds. And if you know the period, you can find the frequency of the signal. But first, let me explain what does it mean t is equal 4 seconds. It means that this pattern or this waveform or this signal from 0 to 4 is going to continue to be repeated every 4 seconds. You have the same thing. Let me just give you another example. Like you have something like that. That's a periodic. And that would be the period of the signal. It's just the same pattern is repeated over and over with the same time t. So that's the period. If you have the t is equal 4 seconds, you can find the frequency. The frequency is equal to 1 over t. So in this case, 1 over 4, which is equal to 0.25, and the unit is hertz. What does it mean, hertz? Cycles per second. So there's difference between the period and the frequency. The period, it means one waveform is going to be repeated every 4 seconds. But when we say f is equal 1/4, it means in 1 second you can see quarter of the cycle. Okay. You can find the angular frequency. Both are frequency, but this is cycle per second on hertz, and this one radian per second. How you get it? You just get this f and multiply by 2 pi. You get it in radian per second. Okay, so that's how. How can you check that this is true? You can verify it. Yes, you can check. If you pick any time, at any time here, anytime, like 1 or something like that, and then you measure t, the period 4. So if you have 1 here, 1 and 4 will be 5. They should have the same value. So let's check here. I picked here at t is equal -2. So the period is equal 4. If you add -2 to 4, you'll get x of 2. If x -2 and x2, they are equal, so that's true. It's periodic and the period is equal 4. So that's the way to check. So how we check if the signal has a period 4, it means x of t anytime, 0, 1, -1, -2, anything, it will be equal to x t, this time the choose, plus the period t, which in our case 4 in this case. In this case I picked -2, and then I check if they are equal. I found they are equal, so that proves that's periodic. Okay, that's for the continuous time signal. Remember, t has to be a positive number. In this case it's positive 4. You cannot have negative number. What about discrete? The same thing, but the period here, we don't call it t capital, we call it n. Let's look at this one. So you have the value is 0, and then going 1, 2, -2, and then -1, and then 0. It look like this one, and it's going again. That's 1, 1, and 2, 2 is going to be repeated. So you can say this is the period. And this is n. So it's n 5. So the period of this signal, which is discrete time signal, is equal to 5. What does it mean? It means x of n is equal x of n plus 5. If you pick any number n. Any number n. Like here I picked n is equal -3. So you find the value x -3, 0, -1, -2, -3. At -3 is equal to. All right, that's equal to. And then if you add to n 5, and you have n is equal -3, you add 5, so it would be x 2, x of 2. What's x of 2 here? That's x of 2 equal to the same value. So you have x at n equal -3 is equal to, and when you add the period n, you get also 2. So that the proof that it is yes periodic and the period is equal 5. That's great. So that's how you can find the period of any signal, if it's discrete time signal or continuous time signal. And the same thing for the discrete. If you want to find the frequency, the same thing will be the frequency is equal not 1 over t, but 1 over n. And in this case, n is equal 5, so 1 over 5. So that will give 0.2. That's the frequency. You find omega. We don't write omega like that in discrete. We use the capital omega. All right. It will be the same thing. 2 by not f. 2 by this f or over t, which is n. That's what you get, 0.4 pi. So it's the same, similar, very similar, but just the only difference, instead of using t capital as a variable, use n. Okay. I'm going to take a special case for sinusoidal function. If I have sinusoidal function, it's a periodic. And when it's a periodic, when I say sinusoidal function, it means it could be sine or cosine. That's the general form for cosine. X of t is equal cosine omega t plus theta. And you know that omega is equal to by f, or 2 by, f is equal 1 over t, 2 by over t. So from this equation, you can find t, the period, is equal 2 by over omega. That's important. So how can you find the period of a continuous time signal? You divide 2 pi by omega. That's an example. X of t is equal cosine 3 pi t, cosine omega t. So omega is equal 3 pi. You find omega equal 3 pi. You want to find the period. How you find the period? You divide 2 pi by omega. 2 pi and omega is equal 3 pi, and cancel will be 2 over 3. So the period is equal to over 3. Great. All right. What about the discrete? Discrete is very similar. You see, you have cosine omega t plus theta. You have cosine omega n, not t, because that's have to correct x of n. The discrete always written like that, x of n. So x of n is equal cosine omega and capital n, not time t, n, plus theta. All right. The same thing. How you find t is you divide 2 pi by omega. How you find t, not t. This is that's the period, okay? N, it will be 2 pi over omega. The same thing. All right. So let's just take an example. Sine n pi over 12 plus pi over 4. Forget about this angle, just we are looking for that. That's omega n. Oh, that's omega n. So that's n. So omega, in this case, omega is equal pi over 12. That's omega. Pi over 12. There's no n here. Pi over 12. How you find the period? Similar, see? We see t equal 2 pi over omega. We see n equal 2 pi over omega. Capital. 2 pi over, what's omega? Pi over 12. That will be equal to pi, cancel pi, 12 goes to 24. So n, the period, is equal to 24. Okay. I'm going to elaborate more on the discrete, because it can be tricky a little bit. I have here 2 examples. That's for the time. That's continuous time. That's easy. I will just do the first one. Sine omega t. So omega, in the first example, pi over 12. So what is the period? T. We'll say 2 pi over omega. 2 pi over omega, and omega is equal pi over 12. Pi cancel pi, that's 24. Okay, that's great. The second one, omega, that will be omega is equal to 0.5. So t will be equal to pi over omega. 2 pi over 0.5. is equal 4 pi. So the period is equal 4 pi. Okay. I will now go for the discrete. Sine pi n over 12 plus. So I will say, I think, yeah, we did that with 24. Let me go for the second one. The second one, x of n sine 3 pi n over 10. So what's for b? Omega is equal what? 3 pi over 10. 3 pi over 10. So n, the period for the discrete, will be equal 2 pi over omega, and omega is equal 3 pi over 10. Pi cancel pi, so you got 10 will be 20 over 3. N cannot be fraction. N, the period cannot be fraction, should be integer. So you multiply it by m. Now you ask, what's m? M, that's integer. You are going now to choose from the smallest one, start by 1, 2, 3, the smallest one. Whatever it work and get the whole thing integer, that will be your n. So I try first m equal 1. We try m equal 1. What's the result? 20 over 3. No. When you try m is equal 2, will be 40 over 3. No, it's not, because it's not integer. Take m equal 3. You will have 20 over 3 times 3. Cancel, it will be 20. Yes. So the period of this sequence is equal to 20. So in discrete, when you don't get an integer, multiply it by m, and m is a positive integer, you start with the smallest one till it work out and you get integer. Okay, let me do the last one. See, n is equal 4 pi, I'm sorry, here that's omega, for c is equal 0.5. So n is equal 2 pi over omega. So to equal 4 pi. Of course, not integer, because pi is irrational. If you multiply by m, and m always will be integer, like 1, 2, 3, whatever the integer you do, you cannot get rid of pi. So it doesn't have a period, you can't. Okay. Now let's move to another thing. What about if we are adding two sine wave? Sine or cosine, I mean sinusoidal, when you're adding two or two periodic signals in general. So what you will do, if you are adding two periodic signal, x1 and x2, you are going to get the resultant x of 2. Well, the question is, what is the period of this x of t, which is equal to the sum of both? First thing, you find the period of the first signal, find the period of the second signal, and then divide t1 by t2 and simplify this ratio till you get something co-rhyme, q over r, for example. So it means if you multiply r by t1 will be equal q by t2, both they are equal to the period of the resultant signal. Maybe it doesn't look simple, but just let's have here. That's example. x1 of t is equal cosine pi t over 2. Let's just find the period here. The omega 1 is equal pi over 2. So t1 will be 2 pi over omega 1 pi over 2. That will cancel. So 4. So t1 is equal 4. Okay, I got the period of the first signal. Now I'll go for the second signal, x2. What's omega 2? Omega 2 pi over 3. So t2, the period of the second signal, is equal to 2 pi over omega 2, which is pi over 3. Pi cancel pi, 3 go up, multiply by 2 will be 6. So t2 is equal 6. Now I will do the same. Now I want to find the resultant when I add x1 to x2. So as we agree, we'll find the ratio between t1 and t2. t1 is equal 4 and t2 is equal 6. And then we're going to simplify it. So by 2 is equal 2, by 2 equal 3. You simplify it till you get the smallest number there. So that's the smallest one. You cannot simplify it more than that. So what's happening now, if you cross multiply 2 times t2 is equal 3 times t1, that's equal to the period of the resultant signal x of t, which is equal x1 plus x2. So of course you tell me which one you're going to use. Are you going to use 3t1 or 2t2? No, anyone, doesn't matter, but they're equal. So let me just get this one. So in this, t is equal to 3t1 and t1 is equal to 412. So it means if you are adding x1 to x2, the period of the resultant signal has a period equal to 12. And that's it for the periodic, and we'll